this triangle ABC, the centroid is actually the actual center or balancing point. So if you were to take the centroid of a triangle, Harley, put your phone away, okay? Put your phone away, please, Corn. If you were to take the centroid of any triangle and you were to put it, like, balance it on something, it would balance there. You can't do that with the incenter and the circumcenter because it's not the actual middle. This is the actual middle. We're going to find medians, right, of these lines, okay? It's the actual balancing point middle. Yeah, it is the centroid. Say. So with your compass, you have this triangle here. We're going to, so do you guys remember, let's just take this line AB right here. Yes, you should have that triangle drawn. We're going to find the midpoint of AB. Now, do you remember how to find the midpoint of a line with a compass? Okay, here's what you do. So follow my instructions. You're going to take your compass and let's put our compass point on A to start with, okay? Make sure you spread your compass heading out to where it's more than halfway between A and B. And it doesn't have to be exact as long as it's, see, mine's more than halfway right there, right? The compass heading is more than halfway from A to B. You got that? Okay, then we're going to take and we're going to make an arc out here, okay? And then we're going to spin my compass and make an arc out here somewhere, like that. Okay? Does that make sense? We good? Yep. Okay. Then you're going to flip your compass and put the compass point on B. Don't change the compass heading, though. If you do, you have to redo it. You got to keep the over the halfway mark at least. Okay, and then you're going to put your compass point on B and make an arc that crosses that. Okay, and then you're going to spin your compass over to the, ooh, I'm going to have to redo my arc. So notice, this is actually a good thing. See that arc right there, how they're not crossing? Yep. So now what I have to do is I have to flip my compass back and put it back over here and make sure they cross. See how now they're going to cross? Move my compass. Mine won't cross at all. It will. It eventually will. Okay. I'll get rid of this one. So that, I'm going to move my compass off. So that's what I have there. Okay. Does that make sense? So if I connect this point here and this point here, let's go ahead and do that with a line, straight edge. Make sure you're using a straight edge.
Oh, I think I found the issue. I didn't go point.
So this point right here, we'll put it in red. This point right here is the midpoint between A and B, right? That should be a review. We've done that before, okay? So now what I want you to do with your eraser is clean this up a little bit. Get rid of your arcs. Every time you do one, get rid of your arcs, because what that does...
It's easy for you.
Well, you have an eraser, I would hope. Okay, so that's what you have, this midpoint right here, right? And actually what I'm going to do as well is get rid of that line right now because I have the midpoint. And I'll show you a little bit easier way here in a moment. So now I have this midpoint between A and B. The opposite angle is C, clear over here, right? So now what I want you to do after you've got it all cleaned up, take and draw from this vertice C to the midpoint between A and B from the opposite angle. Okay?
Wait, should mine cross right on this line?
Let me see.
Mine crossed over here.
Yeah, but you need another one down here.
Oh.
See, and then you connect them,
Yeah.
and then that'll give you the midpoint.
And
okay.
Do I do it from B to C?
So you've got to have the same compass heading.
Oh.
Right there. That's pretty close. Right there. And you have to have one over here.
Oh.
And then you have to do that. Right there. Now see where that crosses and that crosses? That's going to be your midpoint right there. Okay? Okay. So this line, there's a new name for it. What do you think it's called? Anybody want to guess?
The center line. The median.
That line
Oh my gosh, thank God.
right there is the median. That's the median line. Okay. So I'll do this. That is a median line right there. Oh, let's do it this way. That's called a median. How many medians do you suppose there are on that thing?
3.
There are 3. So here's what I want you to do. I want you to take, now, do the same procedure. Find the midpoint from A to C. Find the midpoint from B to C. And draw the median lines from B to the midpoint AC, from A to the midpoint BC. Okay? That's what I want you to do right now. I'll do the same. Okay, so the centroid of a triangle is where all 3 medians meet. Okay? So we've got 3 things now. We've got a circumcenter, right? Which is the perpendicular bisectors of all sides, where they meet. We've got the incenter, where the angle bisectors meet in the middle of the triangle, or, well, the incenter can be outside or inside, right? And then we've got this, the centroid, where all 3 of the medians of the triangle meet, okay? Does that make sense? All right. So, draw another triangle, okay, and label it like this. So we've got triangle JKL, and then we've got, they went ahead and found the medians for you, right? So this point right here is going to be called what? That's the centroid, because that's where all the medians meet, okay? And they gave you this distance from P to T is 2 centimeters. So go ahead and draw that, and then we're going to talk. Okay, so in your notes in that sketch on the board, it says P is the centroid of triangle JKL. And the distance from P to T, P to T is 2 centimeters. Okay, so write that in your notes, and I'm going to show you how this works. Is everybody ready? Huh? Yeah? Did it work? It must have, because it must have. Okay, so here's the cool thing about centroids. This distance right here, K to P, is exactly 2/3 of the distance from K to T, which means this distance is, that's 2/3, that's 1/3 to make a total line. And it always works with a centroid, okay? This is 2/3, and this is 1/3 of the total line. And the same goes for these right here. This right here is 1/3, oh, not 1/2. This is 1/3 the distance. This is 2/3 the distance of the total line, okay?
So that's 1/3.
So if you take this, let's just take KT here, this whole distance from KT. Let's say that line is, you sure?
Because that 2 is 1/3 of it.
Well, let's test it and see. I'm going to erase some stuff on my board. And let's do this algebraically, because I know how much you guys love algebra. Okay? So let's take this. So we've got, let's deal with this distance right here. Let's deal with this whole distance, because we know that that's from P to T is 2 centimeters, right? So, we'll do it in red. Okay? So, if we know this, 2/3 and 1/3, right? And we want the whole distance. Let's find this distance KP, okay? Because we know the other one's 2, so let's find KP. So KP is equal to what? 2/3 of what? Which is KT. 2/3 of KT is KP. Does that make sense? Do I need to slow down and back up? Brad? You got it. Okay. So let's take KT and let's break it into 2 segments because there's 2 segments there, right? So KP also is 2/3 of the distance from KP plus the distance from PT. Right? That makes sense. If you add this section right here and this section right here, you get the total KT, right? That equals the total line. Does that make sense? Yes? Stop me if it doesn't, because this is important. You're going to be tested on this. Okay? So here's our equation. What do we know? PT is 2. So plug that in. KP equals 2/3 of KP. Oh, not KP. That's not right. They won't be tested on that. This should say KT. This whole thing is the total. Sorry, my fault. Those are KT, not KP. You guys got it? See what I did there? Just erase it and rewrite it.
That's right over.
Okay, we good? Right there? Is everybody with me? So the total line, KT, is the same as 2/3 of KP plus 2. Does that make sense? Because we're just taking those 2 sections. All right? You good? Okay. Did I mess you up? Did I mess it up? Oh, no, I was right the first time. Why didn't you guys stop me? Why didn't you guys stop me? Yes, you did. Thank you. KP. I was right. I was questioning myself. I tried to. There. All right. Now distribute this 2/3 across the whole thing. KP is going to equal 2/3. KP. 2/3 of 2 is what? 2/3 times 2 is 4/3. You're just multiplying fractions.
I did have it right
Look.
first time.
2/3 times 2.
2/3 times 2 over 1.
You just multiply the fractions. Yeah.
3 times 1 is 3.
Yeah. All I did is went like this and this. Okay. You probably are now because somebody belched on the video. Okay. So now what? Do I have any like terms that I can like isolate? Huh? Yeah. I've got a KP on the left, which is 1 KP, the total line. I've got 2/3 KP on the right. So your algebra says you can do this. If I do that, those are going to cancel, right? Harley, pay attention. So what am I left with on the left? What's 1 minus 2/3? Thank you. 1/3. Okay, stop with the noise, please. Now what? You can't take 1/3 away from both sides. That's a multiplication problem. That's a multiplication problem. You either divide or multiply the reciprocal.
4.
Okay, those cancel. What's 4 times 3? 12 thirds. KP is what?
4.
Okay. The reason I did it the long way, that was an easy one, right? Because you're going to come up with some messy numbers that don't always just work out where you can do them in your head. So you have to be able to figure out how to put them together and do the algebra to solve them. So let's just, I wasn't going to do this, but let's do it. Let's go, yeah, bonus math is good. So let's look at RL. Okay, let's look at RL, this line right here. Oh, Ralph Lauren. Let's look at Ralph Lauren. That distance. What if I told you that RP, this distance, was 5? I want to know the distance from P to L. So this is the distance we're looking for. You do the math. What is this distance right there? Based on what we just did. Okay? So you do the math on that, and then we'll talk. This one was actually a little bit easier to do than the first one, but with the 5 kind of throws people because you're like, what? 2/3 of 5? And so, where's it at? There it is. PL is 2/3 of RL, right? PL is what we're finding. It's 2/3 because it's a centroid. PL is 2/3 of RP plus PL, which is the total. Okay. And then you move down to PL equals 2/3. We knew what RP was. This was 5. Right? So we just plug that in, distribute this across from there and there, and you get 2/3 times 5 is 10/3 plus 2/3 PL. Subtract 2/3 PL from 1 PL on the left. That's where you get 1/3 PL equals 10/3. Okay? Multiply each side by 3. I should do this to tell you what's multiplying. And then PL equals 30 over 3 or 10. Which makes sense, because if you look back here, if this is 5 right here, right, and that's 1/3 of the total, what's 1/3 of the total if this is 10? So this whole line is 15, and 1/3 of that is 5, 2/3 of that is 10. Okay? It's pretty simple that way. Okay? All right. Yeah, we have time for this. We do have a word problem. You need a piece of graph paper for this one. I don't know if we're going to get to it. I hope so. So, a performance artist plans to balance the triangular pieces of metal during her next act. When one such triangle is placed on the coordinate plane, its vertices are located at 110, 50, 95. What are the coordinates of the point where you should support it? You need to find the orthocenter of that triangle is basically what they're asking you to do. Yeah, do it in your notes. I mean, sorry, not the centroid, not the orthocenter. You're going to find the centroid because that's the middle part of the triangle.
I don't know what orthocenter is, but I'm pretty sure it's the centroid.
Yeah. Okay, so find the centroid of that triangle. So here's my triangle from this slide, and I'm going to use the midpoint formula on my calculator to find the midpoints of these lines and see if it comes out. Does it come out good? Are you guys doing it already? Okay.
Yeah, it does.
So in programs, okay, you can do this longhand too, but the programs are better. So I'm going to use midpoint number 4 on my calculator. So the first coordinate was 110. And the second one was 50. And if I do that, the midpoint is 3,5 of that first line. So if I go back here, for this line right here, it's 3, 5, and I'll do it in red. So I'm going to go over 3, and I'm going to go up 1, 2, 3, 4, 5. There's my midpoint right there. Okay? I'm not going to draw the medians just yet. My next point was 110.95, so I'm going to go back here. I'm going to go 1, 10, 9, 5. Midpoint is 5, 7.5 is the midpoint. So I'm going to go back here, and I'm going to go over 5. 5, and I'm going to go 1, 2, 3, 4, 5, 6, 7. 0.5 is right there. And then the next one is 5095. 5095. And that's 7 and 2.5, right? So I'm going to go over 7 and up 1, 2.5. There are my midpoints. So after that, I'm going to draw lines. I'm going to draw the medians, right? So I'm going to go from this vertex there. I'm going to go from this vertex to the opposite. This vertex to the opposite. So there, right there, that yellow dot right there is my, what is it called? Centroid, right? That's the exact center of my triangle. What point should that be at? What is that coordinate? 5, 5 is the centroid of that triangle. It's 5, 5. Actually, let's do it like this. That right there
What is the point between 5 and 5?
What's the what? What's the midpoint here?
Yeah.
It's 7, 2.5. 7, 2.5 is what it should be. Okay, so that I'll probably pause this video because it's 22 minutes long right now. That's how long it takes. So I'm not gonna edit. I'm just gonna put it right out there. Maybe I'll edit it. Okay, not very long. So we're gonna stop right here, and that's how to do a centroid. I'll do a new video on altitudes. Okay, we'll start that maybe today. Okay, altitudes of triangles. So that's how to find the centroid on a coordinate plane. That's how to find a centroid when they give you information like this. Okay.